anyone can go anywhere, but in terms of service, we will not allow any service out there. We will use HTTPS, HTTP, all right, and DNS. All right, now let's just apply that, and that's a good way to create a policy that is more granular. So to create a firewall address object, we'll go to policy and objects, addresses. Now let's decide that our firewall address object will be for the marketing division. That's at the 10.0.5.0 subnet. And we know that we have a user that has the 10.0.5.3 IP address, and we want to limit it from sending pings, sending ICMP protocol pings. So how do we do that? We go to the policy and objects, addresses, create new address. Now let's name our computer limited ICMP. That's a nice name. Let's use the IP range, and let's use the 10.0.5.2 up to 10.0.5.2, or we said that it will be .3. And the interface is the marketing interface. Okay, we can also use static route configuration if we want to use it in a specific static route, but we don't need it for now. Let's just apply that. And now let's create a new policy, and in our new policy we will name it no ICMP for that specific device. So the incoming interface is marketing, the outgoing is the WAN interface, and the source is the new limited ISP source that we have just created. Destination all, service ICMP, we want to limit it from sending ICMP ping. So we'll choose all ICMP and ping, and in the action we will choose deny. Okay, so now we have a policy that denies ICMP or denies pings from that specific users. Now for that policy to work, we need to actually move that policy before the marketing policy. So our firewall will look at that policy, will understand that that specific device, which belongs to the marketing division, doesn't have full access the same as the other user. It limits him from sending ICMP. Now the next thing you will need to do is to create a static route so that all packets from different interfaces will know where to go in order to get out to the internet. So to do so, you'll go to network static route, create new static route. Now I have already created one here. That's my static route. The destination is all zeros. That is, every packet that is destined anywhere and doesn't have a route in the routing table will go through that static route. You will need to choose the interface. In our case, that's the WAN interface, which is connected to our ISP router. We will not look at the administrative distance or the priority of that route, but know that you can actually prioritize different static routes on your Fortigate firewall. Alright, so we actually reached our final step, final configuration, which is applying security profiles to your policies. Now, you can find security profiles just beneath policy and objects, and you have different security profiles. Each security profile have its own knowledge base, and you can find dozens of videos in my channel that explains how to work with antivirus, web filter, DNS filter. The idea is that you actually create a security profile and then you apply it on your policy. So let's just open one policy, let's edit it, and here you can find the different security profiles. Once you enable it, it actually scans the traffic and looks for viruses, malware, spam, domains that are not permitted, and other things. Application control is probably one of the most used security profiles out there. Now, each application in the application database has its own unique ID. It can be TeamViewer, Netflix, Amazon apps, or any other application. Now, your application sensor actually uses the IPS engine that looks at the different protocols, looks at the different traffic, decodes the protocol, looks for patterns, and then when it knows that a specific application flows through the different interfaces, it tells so in the session list. So let's take a look at how the application unique ID shows up in the session table. Alright, so the very first thing that we need to do is to head over to Fortigate Labs, Threat Lookups, Application Control. Now here we can look at the different unique IDs that each application has. Let's look at TeamViewer. Alright, we have different vulnerabilities, but we will look at the application category. And here we have TeamViewer, and let's just press it. And there it is. That's the unique ID of TeamViewer. The second app that we will look is Netflix. There we have Netflix, and Netflix has the unique ID of 18155. Alright, so let's move to our Ubuntu device. And let's just enable TeamViewer. Oh, there it is. All right, and it is working. So let's move back to our Fortigate. Let's just use the DHCP session list. And we see that we have dozens of sessions. We cannot actually look at the different sessions, so we will use the grep command. And the very first app that we will look is the Netflix app, 18155. 18155. And there we have it. We have a session, that's the session ID. The serial is actually the session ID, and we have a session that actually the Netflix app actually uses. So that's the app ID. So let's get back to our Ubuntu. And let's look at the TeamViewer. It is working. And there we have it. That's the session ID, and that's the app, the TeamViewer app that actually initiated that session. Asymmetric encryption is being used just about everywhere. Let's look at the following scenario, and then we will dive in and understand how it actually works. So let's assume that Eve wants to send a message to Bob. She writes down the message, she encrypts it using its own symmetric key, and then when it is all encrypted, it is being sent to Bob. Now, Bob knows the key. It knows the symmetric key that Eve used. He uses it, and by that, he actually decrypts the message. Now, if you think about it, we actually achieved only one thing. We encrypted the message. But then again, we have other challenges. The first one, how can we deliver the key between Eve and Bob? Let's assume that Eve and Bob doesn't live close by. The second challenge is, how can we tell that the message wasn't modified? How can we tell that no one actually modified with the bits of the message itself? And the third challenge, how can we tell that the person who claims to be Eve is really Eve? For that, we have asymmetric encryption coming up. When Eve encrypted her message, she actually used asymmetric encryption, and the key that was used by the algorithm was known also to Bob. Let's just take a look at the terminal and let's just make it bigger, and let's generate a random key. So we'll use for that OpenSSL rand, which is a command that allows you to generate pseudo-random numbers, integers. Let's use a key in hexadecimal, and let's use an 8-byte key, and that is the key. That is the key that could be used in asymmetric key encryption and that both parties should be aware of. So if we get back to Eve and Bob, Eve used this key with its algorithm. It could be either AES, it can be DES, it can be 3DES, any symmetric encryption algorithm. And Bob used the same key. So both parties has the same key. They both know that the algorithm is either AES or 3DES, and the message could be decrypted on the other side. On asymmetric encryption, Eve actually generates two keys, key pairs. They may look similar, but they are actually different, mathematically related, but different. The first key is the private key. The private key is actually the secret key that Eve needs to keep in a secret place. The second key is the public key, and as the name suggests, it is public. Everyone can use that key. Now, when Bob gets the key, it can use it for asymmetric encryption and actually decrypt messages that were sent by Eve. It can also encrypt his own messages using the public key, and from there just send it back towards Eve, and Eve can decrypt it. So if we'll go back to OpenSSL, let's just write down OpenSSL, GenRSA. RSA is one of the algorithms of asymmetric encryption, and we'll use the 2048-bit key. And that's our private key. That's our private key. We can actually generate the public key from the private key that we have just generated, but that's the private key that Eve has actually generated, and as we said, it should be kept secret. And there we have it. Eve generates a private key and a public key and sends the public key again to Bob. Now Bob gets its public key, and from now on it can decrypt Eve's messages. Now think about it. The fact that only his public key can decrypt Eve's messages suggests that the message actually came from Eve. That's one way to authenticate the other side. Now, in fact, asymmetric encryption is not used to encrypt the session itself, the data, the payload that is being sent from Eve to Bob and vice versa, for many reasons. One of them is the size of the keys. So what actually is being done is that the private and the public keys are being used to encrypt the session keys, the symmetric encryption keys. They are much smaller in size, and they are being decrypted and encrypted much faster than asymmetric encryption keys. So Eve can actually generate a pseudo-random key that is a symmetric key, encrypt it using its own private key. Bob can get the encrypted message, open it with its own public key, and now he knows what is the symmetric key that Eve will use to encrypt the whole session. Auditing your firewall is a major task that you need to do from time to time. Now, there are companies that release tools that will allow you to audit your firewall, but here is the 10 best practices that you can start with. The following best practices are not in a specific order, so just use them as you wish. Now, another thing, I'm showing it on a Fortigate firewall, but you can also do it on a Checkpoint firewall, on the Palo Alto firewall, any next generation firewall. Quite obvious, but we do it on any device, any servers that we have on our organization. Be sure that your firmware is up to date. Always use the latest firmware. Usually the latest firmwares are much more secure. Your firewall vendor will always make sure that you have the latest patches on the latest firmware. So back up your configuration, look at the release path, and update your firmware. Encryption and high encryption is fundamental in your firewall. So be sure that you always use the strongest algorithms. Now, it's not always possible, but assuming that the other side also supports the strongest algorithms, just find out the appropriate CLI command on your firewall and enable it. So in a Fortigate firewall, it is config system global. Now it may change from firmware to firmware. Set crypto strong and just be sure to enable it. Always make sure that your administrator is connecting to your Fortigate through a trusted host. That is a trusted IP address as the IP address at its home or in the office. Now, you can do it using the graphical user interface. You can do it using the CLI. Let's do it using the CLI, config system admin. Let's edit the admin. And from here, set trusted host. And just write down the trusted IP address. If possible, on your WAN interface, your external facing interface, don't allow any administrative management. So let's just use the config system interface, edit port 1, which is my internet facing interface, and unset allow access. On your LAN interface administrative access, try always to use HTTPS and SSH, that is HTTPS to the graphical user interface and SSH to the command line. Now try to avoid ping and try to avoid other protocols unless needed. The following is probably one of the first audits that you need to do. Look for unused rules, rules that were asked time ago and configured on your firewall. Look for them, and if they're not relevant anymore, just delete them. Now, a side note, document any rule that is asked. Document who asked the specific rule and the time that it was configured. Your administrator should always log into your Fortigate or any other firewall using HTTPS. So be sure that even if it tries to do it over HTTP, your firewall will redirect the request over HTTPS. So let's do it here. Config system global, set admin HTTPS redirect. Another setting that you should be aware of is the admin lockout and the admin lockout duration. Now, that should comply with your organization policy. Config system global, And now let's set the admin. You can set the admin lockout duration. The default is 60 seconds, but you can set it to 5 minutes or more. That should comply to your organization policy. Now, another setting is the threshold itself. That is, the lockout threshold is actually the number of failed attempts, when your admin tries to log into the system. The default is 3, and it is a best practice to keep it at 3. Logs should be part of your auditing. That is, when you audit a firewall, be sure that logs are there for at least 7 days. Now, look at the proper documentation of your firewall. Let's just do it here. Config log disk setting, set maximum age. Now, you can set it to 7 days. You can also set it to 30 days. It depends a lot where you save the logs, either on your hard disk or towards a syslog or any other device that has a proper storage. At last, let's look at some more best practices to hardening your firewall. One of them is when you have unused interfaces, disable them. If you have interfaces that you want to disable different protocol, so just disable them using config system interface, edit the interface that you want to disable, and there you can unset DHCP relay services. You can unset PPTP client, ARP forwarding, and so on. Another thing that is quite common to any Fortigate out there, and that is something that I'm not familiar with other firewalls which have maybe, yes or no, the same functionality, is what is known as the maintainer account. The maintainer account is actually a backdoor to your Fortigate. If your admin has lost its password, then it allows you to actually boot into your Fortigate using what is known as the maintainer account, which is actually the serial number of your Fortigate with the maintainer user. So you can actually disable it. In most Fortigates, I believe that it is enabled by default. Set admin maintainer account disable. Automation is fundamental to every security appliance out there, and Fortigate is not different. Now, you can use automation in different ways. We will look at the security fabric automation stitches coming up. The idea behind automation stitches is quite simple. That is, it is very similar to if this then that. You choose a trigger and you choose the action that will follow. So let's create our first stitch. Let's name it reboot. The trigger is the machine that has just rebooted, and the action can be one thing or several things. We will choose two. The first one is CLI script. In the CLI script, you can actually write down any script. Let's just write down the most basic one, which is get system status. And the second thing that we want to do is to add up an email, so the output will be sent to the administrator email. Let's just write down the subject: machine has just rebooted. All right, so that's our first stitch. Now you can create stitches with schedules. So for example, you can create a backup stitch. Here we will schedule an event which will be the backup. It will happen weekly in 12 o'clock and on Sunday when no one works. Now the action itself will be a CLI script, and the CLI script will be the execute backup config USB. Let's name it backup. We can also add up the password for that backup. Now the idea is that you actually can do a bunch of things using the automation stitches that will help you to offload different tasks as an administrator. So you've got your new Fortigate. How do you configure it? Coming up. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you've got your new Fortigate and your new two Fortigate firewalls. What do you need to do? You have probably connected your Fortigate using a network cable to your computer and configured it. Fortigate appliances comes with at least port 1, one of the ports, which is usually port 1, that is already configured with the IP address of 192.168.199. You need to configure your PC subnet to be on that same subnet, get to the IP address of the interface, of the port 1 interface, and from there you're actually starting to configure your Fortigate. Now you can configure a Fortigate using the graphical user interface, which has many features. It even has a feature visibility feature in the system settings, so that you can disable or enable new features which are not available over here. Now you can configure your Fortigate using the graphical user interface, and you can configure it using the command line. Fortigate experts use the command line almost all of the time. We will look at the command line, but we will make our way using the graphical user interface. To get to the command line, you need to click here. It is actually a JavaScript app that runs on top the admin web app. Probably the first thing that you want to do is to write down get system status, so you can see your Fortigate serial number, which ASICs, which accelerated hardware does it support. Are you using a hard disk or a flash drive? The current security profile database, and so on. Now we went into the interfaces. You probably have one interface that you're connected to, which will be the management interface. Now you need to connect one of your WAN interface to your ISP, either through a modem router, or you can use your Fortigate as the router itself. Each interface has a physical switchboard that you can connect to different subnets in your network. Now let's just edit one interface. Let's see what's inside. You can name your interface according to the subnet in your local area network. Let's assume that we have a management subnet. All right, now you can define it a specific role. It can be a WAN, a DMZ, an undefined role, or a WAN. So let's use the LAN. So now we know that we have a management LAN connected to port 8 on our Fortigate. Now, the addressing mode can be manual, it can be DHCP. Let's use the manual option and let's configure it to be 192.168.2.1/24 since we're using a 24 subnet. Now, this address is the gateway interface address. So any computer that will connect to one of the to port 8 will get an IP address in that subnet, that is the 192.168.2.0 subnet, but its gateway address will be 2.1. Now we will also open the DHCP server, so anyone that is connected, there's a pool of IP address that it will grab. We'll look at DHCP server very soon. Before that, we need to configure administrative access. Which protocol will support administrative access? We'll just use HTTPS and HTTP. For now, we can also use SSH. We can also configure it to support pings from host in that subnet or from a Forti manager, but we will not do it right now. LLDP is a protocol that enables discovery between devices in the network. It doesn't really matter. You can disable or keep it for now. Now we have a DHCP server. As I said, any client that connects to that port will receive one of the IP addresses from the pool. You don't have to use all the pool. You can use only 20 IP addresses. You can keep the DNS server the same as configured here, or you can specify your own DNS server. Let's just specify Google's DNS server. You can control the list time, and if you click on the advanced, if you have a DHCP server that is part of your domain, which is not your Fortigate or your Fortigate interface, you can configure its IP address here, and then whenever a packet arrives on that interface, it will head over to the DHCP server. But for now, we're using the gateway interface as the DHCP server. You can configure an NTP server. You can configure, and this option is for more advanced users, DHCP scopes or options. And you can assign different IPs to different devices based on their MAC address. Another option is device detection. Device detections allows your Fortigate to detect which device and which operating system devices on the networks belongs to. This is one of the things that you should keep enabled. Don't bother with the explicit web proxy. You can enable a captive portal, so if you have outsourced employees and you wish to jump a landing page with user credentials, you can also do that, but we will skip it for now. So this is the basic configuration of the interface. Okay. So now we have a management interface. We have another interface, which is the WAN interface that you connect it. You connect it to your ISP router. We will call it WAN1. The role is WAN. We can use DHCP, and if we want to make it more reliable, we will use a static IP address. So my gateway interface is 10.0.3.75, and my router is actually 10.0.3.1. I've enabled HTTP and HTTPS. And as you can see, you don't have a DHCP server whenever the role of your interface is when. That is one of the best practices when using an interface as a when interface. Okay, so we have a management interface, we have a when interface. Now we want to make our managers that are connected to that port, which is port 8, to get out to the internet. So the next thing to do is to configure a policy. Now we will configure a very basic policy, which is a full access policy. Let's name it managers 1, and the incoming interface is management. That's the LAN interface of our managers. The outgoing interface is when1. That is the interface that is connected to our ISP router. That is the interface that takes them outside of the LAN towards the internet. Now when it comes to source, for this video, let's make it very generic. Anyone can go. Anyone. We can configure user groups and different users. We can also configure sets of parameters that control the different users. But for now, as for source, anyone can get out. As for destination, they can go just about anywhere. We can also create specific objects that will allow them to go to specific places, but for now they can go just about anywhere. As for scheduling, we're not limiting them to specific hours or days. So as for scheduling, again, they can get out to the internet any time of the day. As for service, we can deny them from getting out in specific services such as FTP, but for now, for our specific policy, we will let them use just about any service. Now, the action is accept. We can also create a policy that will deny specific services or specific users from getting out or from doing specific things. For now, the action is accept. Inspection mode is another topic that we will look into. That is the inspection that is done to our networks when we're using security profiles such as antivirus or IPS. For now, we will keep it at flow-based mode. Now, we will use NAT. NAT is Network Address Translation. That is our private IP address, which can be 192.168.2.6, will be translated to your Fortigate or to your ISP public internet address. Now we will not use security profiles. You know what? Let's use antivirus. Let's use the default profile, the default antivirus profile. We will use certificate inspection. When we use certificate inspection, your Fortigate checks the different fields that are coming from server certificates to see if they're valid, if it doesn't have any mismatches, and so on. The last thing is to use our logging options. We can log only security events, but we will log all sessions. So later on, we can look at the login report and see what our users or what our host did. Okay. So we have a managers 1 policy. We have 2 interfaces the WAN one, which connects us to the outsides, and the management interface, which managers in our company can connect to and get their IP addresses. That was the second step. Now the third step is to configure a static route. A static route is actually, for our usage, will be a default route. That is, I've already configured one, so let's just look at it. If you want to create new, you just create new. So default route actually tells your Fortigate that whenever he sees a packet, any packet that is destined to any place which doesn't have a route at the routing table, it will route it towards the WAN interface. And the WAN interface address is a 10.0.3.1. Remember, my ISP router has that address. Now you can use specific parameters as distance. You can use priority. It just tells me that I already have that static route, which I do. And once we have a static route, a policy, and the interfaces that are configured correctly, we can now connect our host to the management interface, and those hosts can now get onto the internet. Let's just move to the CLI, and let's see how do we configure interfaces using the CLI. So for the sake of our purpose, let's configure port 7. So using the CLI, we will use the config system interface. Now let's edit port 7 as we said. Let's set its IP to 192.168.4.1 with a subnet of 24. Let's set the management protocols to HTTP and HTTPS. And what else? We can use many more. If you will look at the, let's end it. Now I want to show you something. When you config system interface, let's just get out here. Config system interface, and if we look at port 1, for example, we can use the show full config, and as you can see, there are dozens of features of configurations that you can add. For our sake, we have only enabled the IP address on that interface, and let's look at it. Let's just refresh our page. Port 7, and there it is. Now we can also configure the DHCP server and so on. We have not done so on our CLI. The last thing I want to show you, once you get into your Fortigate, you're actually the Fortigate administrators. Now you have two types of administrators on, actually you have more than two types, but the two most common types is a super admin, which is you. You have privileges to just about anything. You can read and write, and you can create another type of administrator, which is the professional admin, where you can actually enable it, different read and write privileges on the different places on your Fortigate. if you will head over